All right, 2.4, example 4, we're looking at standard transformation form. On example 3, we looked at putting this function into standard transformation form. And the parent function was the radical function, so we even sketched a graph at the end. We talked about by a factor of, and we learned today on the warm-up that this should actually not only be greater than 0, but greater than 1. Whenever you say by a factor of, it should be greater than 1, because you're going to tell me which direction it goes. So in the end, we ended up with this as our standard transformation. So if we want to write that in general form for any function, which is what we're going to do down below, we can write that as h of x equals. The 1/2 is your a value, and then instead of the square root of x, I'm just going to call it f of. Then we got -4 times x minus 1/2, close, close, and then plus 3. So what I just wrote is essentially the transformations that we did up above for the function f of x equals the square root of x. But of course, transformations of any graph are going to be affected the same way by these types of things in the equation. So, what? Yes, absolutely. Without the f, then you just have multiplication. So this is for any function f of x, if you apply this transformation to it, it's going to do the same thing it did to the radical function. It's going to vertically compress it by a factor of 2. It's going to reflect it across the y-axis. It's going to compress it horizontally by a factor of 4. And then it's going to pick it up and move it right 1/2 and up 3 and set it down. And it works for every function. So what we're doing on example 4 is we're going to apply that same transformation that we did up here to the radical function to each of these parent functions. And it's going to get kind of old, but the purpose is to show you that it does the same thing to any graph that you start with. All right, so I'm going to copy this from my up here, which is kind of nice in Notability, and I'm going to paste it on each one of these. I'll go ahead and do that right now. So if you want to do that as well, it'll be helpful to kind of have it in front of you. Using technology. Okay, so let's go to the first one. Well, we actually got the first one done because it says write it in standard transformation form for any generic function f of x. And that's the template, essentially. That's what we're doing. So A is done. And now in part B, we're going to apply that to a specific function x squared. So let's go ahead and think of what the parent function looks like. Parent function is our, hey, I'm happy to be in a math class parabola. It looks like this and goes up. It has y-axis symmetry, even function, all that good stuff. Now let's go ahead and see if we can sketch the final result in one step, okay? The 1/2 in front is going to make it what again? Compress it how? Vertically. So we'd say it's a vertical compression by a factor of 2. It's half as tall. All right, so that's going to have the effect of making it wider, yeah? When you compress it down, it's wider. What does the negative on the inside do? The y-axis. When you reflect an even function across the y-axis, are you going to notice any change? No, because it already has what type of symmetry? Y-axis symmetry. So we're not going to see anything like that. The 4 is going to do what? On the inside? Compress it horizontally by a factor of 4. Okay, so if we move it down by a half, compress it by a factor of 2, and then we horizontally compress it by a factor of 4, that's going to change how it opens. But we're not actually going to show that. So is this in fact the final shape of the graph? Yeah. Okay. I mean, you could say that it's a little bit wider, and then we compress it, which makes it narrower again. But ultimately, that's kind of the shape. I'm not going to actually measure the steepness of your graph. And the only other thing that we had that changed the orientation was the y-axis reflection, and we didn't even see that because it was an even function. So our final graph, let's choose purple. We are now going to pick up that graph and move it right 1/2 and up 3. So here's 1/2. Here's 3. We're going to put the vertex there. Now, every function, hopefully, has at least one critical point that you can follow and then sketch the graph from there. The vertex on the parabola at 0, 0 is that point. In fact, in Algebra 2, you called this vertex form, right? So if we move it right 1/2 and up 3, it looks like this. And that's it. It's that easy. Now let's go ahead and write the actual equation for it. The equation for it, all we're doing is we're replacing f with x squared. So we'll have a 1/2, and now we're on the inside, squared. And we have a negative 4 times x minus 1/2 and plus 3. And there is that function in vertex form, or standard transformation form. Now, is it still an even function?
No.
No, it's not. We messed up the y-axis symmetry when we shifted it what? Left, right, or up and down? When we shifted it right. When we moved it horizontally, we messed up the y-axis symmetry. All right, let's do it real quickly for this one. Let's go ahead and write the equation first. What does it mean to be inside the reciprocal function? In the denominator. So we're going to have a 1/2 and then a plus 3. And now we're going to have 1 over, and inside, which is where the x is, we're going to have negative 4 times x minus 1/2. So there's what that equation would look like. And if we're going to sketch it, our parent function is 1 over x. So let's go ahead and sketch that in yellow. Remember, it looks like that. The dilations aren't going to really be able to show. We're still going to compress it by a factor of 2. We're still going to horizontally compress it by a factor of 4. That's just going to change the shape of it, right? It's going to be a little bit steeper, maybe less steep. We're not going to show that. But the negative now is important because that reflects it across the what? The y-axis. And what that's going to do, it's going to make these two branches switch now, yeah? We're actually going to have a branch over here and a branch over there. So now it's going to live in quadrants 2 and 4 when you reflect it across the y-axis. So our final shape is essentially this one and this one. Now we're going to pick it up and move it. When I move it right, that moves which important feature? The vertical asymptote. So it's now here at 1/2. And the plus 3 moves what important feature? The horizontal. So I'm just going to call that 3. So those vertical and horizontal asymptotes are important. And notice what I've done here is I've kind of created a new x and y axis, right? And I know the graph lived in the quadrant 2 and 4, so that would be the same as this one. And essentially that one. And that's about as accurate as you're going to need to be. Now, notice in this case, when I cross the y-axis, there's no doubt it crosses the y-axis in positive land because it's above the horizontal asymptote. All right, we'll pick up there tomorrow. We had a nice long warm-up, so we got some good stuff today. Be working on your Halloween project. If you want to run some words by me that you want to use, I'd be happy to take a look at them. Have a great day.